We'll be continuing in Chapter 2 in this video. So we're going to be doing 2.1, but Part 2, specifically talking about the graphs of functions. So the graph of a function is the graph of the ordered pairs in that function. So we're going to be reviewing some graphing skills here. So this one says graph the functions of f of x equals 2x, and then g of x equals 2x plus 4. So these are my two different equations. And you're going to put them in the same coordinate plane, which will be on the next slide. And it tells you what integers to choose for x, so that means whole numbers and their negatives. So we're going to start with -2 and end with +2. So the easiest way is to make a table here. And I went ahead and put the equation I'm going to be using. And again, to find f of x, you're going to replace the x with our x value. So in this case, we know what is f of -2. So f of -2, I'm going to replace my x with a -2, which is -4. Now when you think of this, f of x, that is another way of saying y equals 2x. We're just specifically saying that it's a function. So this is the y value that I just found. So in our ordered pair, the x was -2, and the f of x, which is also the y, was -4. So that is our first ordered pair. Okay, now what is f of -1? So if I replace my x with -1, I'm going to get a -2 for my y value. So that's -1, -2 for my ordered pair. F of 0. So 2 times my x is 0 is just going to give me 0 for the y. So 0, 0. Then f of 1, going to take 2 times 1, which is just 2. So 1, 2. And then the last one, f of 2, would be whatever 2 times 2 is, which is 4. So 2, 4. So on the next slide, we will graph all of these coordinates and see what we have for a shape. So now this equation has a little more involved. Again, this is the same as like y equals 2x plus 4. We're finding what our y coordinate is. So what is g of -2? So it doesn't always have to be an f. It can be a different letter. One's going to be an f and one's going to be a g, so we can tell the difference. So I'm going to replace my x with a -2 and then add 4. So that would be -4 plus 4, which is 0. My first coordinate, the x is -2 and the y, or g of x, is 0. Okay, g of -1, going to replace my x with a -1 and then add 4. So 2 times -1 is -2, plus 4 is +2. So -1, 2 is my next coordinate. G of 0, so 2 times 0 is 0, plus 4 is 4. So 0, 4 is my ordered pair. G of 1, 2 times 1 is 2, plus 4 is 6. So 1, 6. And the last one, g of 2, replace my x with a 2 and add 4. 2 times 2 is 4, plus another 4 is 8. So 2, 8. So that is the table, and on the next slide we're going to graph both sets of coordinates. So I will go ahead, and this was our f of x, and this was our g of x. So I just copied over the coordinates so I would remember what those were. So this ordered pair, -2, -4, would be right here. -1, -2, 0, 0, 1, 2, and 2, 4. So you can see this makes a nice straight line. It's a little hard to draw straight on my iPad, but imagine that is a straight line. And g of x, let me write this in red. So -2, 0, -1, 2, 0, 4, 1, 6, and 2, 8. Again, this is a straight line, but it's very hard to draw straight on the iPad. So those are actually parallel lines. And these are in the form of f of x equals mx plus b. Maybe you've seen this before, y equals mx plus b. Means the same thing. That forms straight lines, and they are called linear functions specifically. And we talked about this in the last video. The vertical line test is an easy way to see if it is a function or not. Or I think of the pencil test. So if I had my pencil, could I hold it vertically without it touching 2 points? Will it touch 2 points in the graph? If it does, it is not a function. Now, horizontally doesn't matter. We're just specifically talking about vertical lines, straight up and down. So if you imagine these blue lines were the pencil, this one does not pass the vertical line test because it hits 2 spots on the black line that was graphed. Then the other one, this parabola, the blue line or the vertical pencil only hit the graph in 1 spot, so it is a function. So the black lines with the arrows, those parabolas, those are the functions they were seeing if they were functions or not. The first one is not a function. The second one is a function. Okay, now we're going to be looking at this graph and using that to find different values. So we want to know what is f of 5. So if you remember, these are when we're trying to find f of x. So really we want to know when is the x equal to 5. So if we find, here's the x-axis, 5 is right here. If we trace it up, it hits at 400. So as a coordinate, when the x is 5, the y is 400. Okay, then thinking of this in reverse. For what value of x would f of x equal 100? So in other words, when is the y going to be 100? So let's try to find where that would be. This is the y-axis, so 100 would be right here. So if I trace that across, it looks like it hits right here at 9. So at f of 9, we're going to get 100, so the x is 9 because that's the same as f of 9 equals 100. Or f of x. You could replace it with an x. And does this pass the vertical line test? Yes, it does. There's nowhere where you would hold your pencil vertically and it would hit more than 1 spot. Okay, next we'll talk about identifying the domain and range from a graph. So to find the domain, we're looking at all the inputs on the x-axis, so all the x values. And to find the range, we're looking for all the outputs on the y-axis, which is all the y values. So we're going to look at where this graph starts on the x-axis. It starts at -2 and it ends at 1. So the x goes from -2 to +1. So -2 is the minimum. The x is in between that and a 1. And I'm using the less than or equal to sign because these were closed dots. So it's saying it could include the -2 and the +1. Another way you could say that is the minimum was -2, the maximum was 1. So that is another way you could write it, interval notation. In the range, we want to know what are the lowest and highest y values. So if we look, it goes on the y-axis, goes from here up to here. So on the y-axis, this is 0, 1, 2, 3. So 0 is the lowest spot it hits on the y-axis. And the y is in between that number, and it goes up to 3 on the y-axis. And again, those are brackets because they were closed dots, so it could include those numbers. So the minimum was 0 on the y-axis, and it went up to 3 on the y-axis. Okay, let's try another one. So this one, where does the x go? So the x, on the x-axis, this is the farthest to the left it goes, and this is the farthest to the right it goes. So that's from -2 to 1. Now you have to be careful on this one. It starts with an open circle, so it could not include that. So that's why I have a parenthesis here instead of a bracket. And the x, it has a closed dot at the end, so it could include the 1. So that's why there's a bracket at the end. So -2 is the minimum, 1 is the maximum. Now the y, my graph, the lowest point on the y-axis is here at -1. The highest that image goes is to the 2. So -1 is the minimum, 2 is the maximum. Now this minimum point is a closed dot, so that's why I have a bracket. I'm going to use a less than or equal to sign for the y, since it could include that. And it goes up to an open dot. So that's why I have a parenthesis, which will be a less than sign without the equals. So -1 is my minimum, 2 is my maximum. It starts with a bracket and ends with a parenthesis. So pages 227 to 228 have other helpful pictures. I think it just helps to look at the images to see how to do those, and it gives you some solutions on how to do those problems. Okay, and finally we'll talk about identifying the intercept. So if you think of an interception, it's where you're catching it, you're catching the ball. So to find the x-intercepts, you're looking for points where the graph crosses or catches the x-axis. So the y-intercepts are where it crosses the y-axis. So a function can have more than one x-intercept, but only one y-intercept. So that's really important. Only one y-intercept is going to be possible. Okay, so here's an example. Identify the x and y-intercepts for the graph. So the x-intercepts are all those red dots. So you can see it crosses the x-axis in 3 different locations, so then you just write those as coordinates. So this one right here is the -3, 0. That's where they got that. And the y-intercept is the blue dot. So this coordinate down here is 0, -6 as a coordinate, and that's where they got this dot, because that's on the y-axis. Okay, that is the end of this video. Please let me know if you have any questions.